remember we talked about yesterday when you have secant tangents with exponents, okay? We don't have it with exponents. A lot of times it's just, well, maybe sometimes, but a lot of times it's just like it's on your pink sheet, okay? But if I take the derivative of secant u, I get secant u tangent u du dx, okay? And the strategy is if I save this derivative, okay, and I change everything else to secants, change all else to secants, okay, then when I take the derivative of the secant, all the secant u's will cancel out, okay? The other strategy is if I don't want to save a secant, if I don't want to save a secant tangent, I can also save, let's see, the derivative of tangent u is equal to secant squared u du dx, okay? I could also save a secant squared u, okay? If I save this, then my strategy is I change everything else to tangent. So change all else to tangent, okay? And then when I take u is equal to tangent u, all the secant squareds will cancel out. When I do this change, I use the Pythagorean identity, and that Pythagorean identity is I tan in a second. Okay, so whatever that that u is, you just repeat it because it's an identity. Okay, so let's look at this problem here. What do you want to do? Do you want to save a secant tangent or do you want to save a secant squared? Okay, secant tangent. So this is going to be the integral of secant 4x secant x tangent x dx. Do you see what I did? Because if I save a secant tangent, then what happens is this 5 secant splits up into 2, right? Okay, so this right here is what I'm going to save. And what does it mean you're going to save it? What it means is you're not going to recombine it with the secants. It's kind of separate. You're going to save it separate. If I save a secant tangent, if I look at my strategy, that means I need to change everything else to secant. Okay, so what I have left, I need to change to secant. Well, I have good news. It's all secant already. You guys good with that? Okay, then I go to the next step, and that is get as many buy one free as I can. Buy one, get one free as I can. In order to do that, what I have to do is distribute everything that I can distribute. Okay, so I take a look at this and I say, what do I need to distribute? Absolutely nothing. So again, I'm in pretty good shape. I'm going to rewrite this because this is a lot easier for me to take the derivative, okay, or to take the integral, okay? So at this point, after I've distributed everything I can distribute, what I do is I go ahead and start integrating, okay? I find my u, okay? Whatever exponent is attached to my u, that's the exponent I'm going to work with. So I'm going to add 1 to the exponent, divide by the new exponent, and don't forget to divide by the derivative of your u. Well, if secant x is my u, what's the derivative of secant x? Secant x tangent x. And then, of course, times dx dx, but that's just 1. Or times the derivative of x, but that's just 1. All right? Do my x's cancel out? Not counting your u, do my x's cancel out? Yes, they do. So this answer is secant x raised to the 5th power over 5 plus c. And I don't care if you put that 5 back in or you leave it on the outside. I think leaving it on the outside makes it a lot clearer, but if you put it back in, that's a good answer also. Any questions about how to do number 1? Okay, let's look at number 2. Number 2, we've done this many times, okay? Students still have trouble with this. Just a few people out there. And I just want to make sure that you understand how to do this. This problem gets broken up into 2 integrals. Do you know what these 2 integrals would be? Or how would you break it up? Okay, so 2x plus 2 on one side. Okay, that strategy is because the derivative of this denominator is 2x plus 2. Good with that? All right, what's going to be on this side? Negative 1. Okay, if you say it's negative 1, then what needs to be true is 2x plus 2 plus negative 1 better be equal to 2x plus 1. Is that true? Good. Guys, if you put a number here, you guys are putting random numbers up here. If you put a number here and you add these numerators together and it doesn't turn out to be 2x plus 1, then you've changed the value. Does that make sense of this integral? And so we can't do that. We can add things in and we can change things up, but we can't change the value of it. Okay? All right. So those are the two integrals that I'm going to work with. The nice thing about this first integral is that derivative is sitting on top. What I have here is a u prime over u, if that makes any sense. Okay. If I have a derivative sitting on top, then this answer is just ln of u plus c. Okay, so I've already figured out the answer to this problem. Okay, and you could do a u substitution and figure out that this is ln of x squared plus 2x plus 3. Okay, on this side, okay, if I divide by 2x plus 2, the x's don't cancel out. On this side, when I divide by 2x plus 2, the x's cancel out, so all is good. On this side, it doesn't cancel out, so I have to do something else. What is this something else that I'm going to do on this side? Yeah, complete the square, okay? So this bottom here is going to be x squared plus 2x plus leave a blank plus 3 blank. Actually, I might want to say, well, I want to do an arc tangent on this, but the thing is, it's not in a form that I can do arc tangent with. Okay, so I'm going to change it to a form that I can use arc tangent with, and that form is using this this weird thing. What's my magic number? 1, okay? Because 2 divided by 2 is 1, 1 squared is 1. Guys, if you add 1, please subtract 1. A lot of you guys are adding 1 and adding 1, okay? That just means you want more, okay? So, guys, you add 1, you subtract 1. You got to not change the algebraic, quantity of this expression, okay? So that means that there's a perfect square here. That's the reason you complete the square. This is x plus 1 quantity squared plus 2. And this new denominator, okay, will replace this old denominator, but they're actually the same. If you follow this out and add it to, you should get x squared plus 2x plus 3, all right? So this is equal to negative 1 over x plus 1 squared plus 2, and there actually is a dx here. I didn't put it, okay? All right, so now I'm solving this problem right here. Oops. Solving this problem right here. What do I do? What kind of problem is it? You should be working the warm-ups with me. Okay, this is an arctan problem. Okay, so this is u squared equal to x plus 1 quantity squared. A squared equals to 2. So what's my u going to be here? X plus 1. What's my a going to be here? Be careful. Square root of 2. Okay. So down here, it's basically a u substitution problem. Okay. I mean, I'm not calling it u substitution, but it is. What's the derivative of x plus 1? 1. So dx is du. Okay. Those of you guys who aren't doing this step, you could possibly miss a divide by 3 or divide by 2, or, some sort of denominator or scalar that you need to divide by. All right, so I'm going to substitute two things. I'm going to substitute my dx, which is right here, and I'm also going to substitute my u, which is right here, right? But this is really just u squared, okay? So let me rewrite this. This is the integral of negative 1 over u squared plus 2, and my dx is du. All right, this should be something on my pink sheet. Is it? Yeah, except for the negative 1. So this is actually negative 1 times, let me pull this out. This right here is on my pink sheet as 1 over a arc tangent u over a plus c. Okay, so this is actually my answer. Let me just put this here. This plus the ln, so ln of absolute value of x squared plus 2x plus 3. Okay, that is actually a great answer. Okay. Yeah, it's the wrong answer, but it is a pretty great answer, right? Because all I have to do is replace my a's and u's, and I've actually even defined it here. U is x plus 1, and a is square root of 2. Okay, so if I come back in here, and everywhere there's an a, I put in square root of 2. And everywhere there's a u, I put in x plus 1. And of course, this negative 1 times 1 would just be negative 1, right? So this will be ln of x squared plus 2x plus 3 minus 1 over square root of 2. Is my a square root of 2? Yes. Arc tangent x plus 1 over square root of 2 plus c. That is my final answer, and that is the right answer. Okay, you guys feeling good about this problem? For sure, guys, on your test. Okay, so make sure that you can do that problem. All right, let's look at this problem. What type of a problem is this integral of x ln of x? Integration by parts, okay? I need to point something out to you guys, though. If you have a problem like this, okay, or like this, which is actually the same problem, okay, or like this, okay, these are not integration by parts. They look a lot like this, but how is this different from this? These are actually just regular U-sub problems. Do you know why? Because what's the derivative of ln of x? 1 over x. It's sitting right here, and the derivative is going to cancel out. Okay, what's the derivative of ln of x? It's 1 over x. I know, like, it doesn't look like 1 over x, but that's 1 over x. It's going to cancel out. What's the derivative of ln of x? It's 1 over x. You guys see that? So this side is a regular U-sub problem, but the derivative of ln of x is 1 over x. If you take x and you divide by 1 over x, your x's are not going to cancel out here. Okay, so this right here is actually an integration by parts. So that means this is u, and that means this is dv, right? Right, Natalie? Nope. Why not? You have to rearrange it. Very good. Why do you have to rearrange this? It's a light bit problem. This is your L, and your X is actually a P, I believe, right? So the L needs to go first. So actually, U equals ln of X. dv equals x dx. All right? On the left side, you take the derivative. What's the derivative of ln of X? 1 over X. Okay, what's the derivative of X? I'm sorry, what's the integral? Sorry, this is integral. What's the integral of X? X squared over 2. All right, let me write this formula. The integral of u dv is equal to uv minus vu du. Okay, so that means u times v here is x squared over 2 ln of x minus vu du here. So minus the integral of x squared over 2 times 1 over x dx. Okay, what is this? What is this simplified? What's x squared divided by x? That's just an x, okay? And that's what I did, okay? And what you have to understand is this is the answer. This is the answer to the integral of x ln of x dx. It's just that I have another integral to solve. Does that make sense? But this is the answer. What is the integral of x over 2? Do I know what it is? Yeah, it's x squared over 4. So this is x squared over 4 plus Charlie, and I'm done with this problem. Okay? You guys comfortable with that? Okay? And for sure, on your test, I think I have a similar problem, but you have some limits here. So make sure that you're comfortable plugging in ln of e, ln of 0, not ln of 0, ln of 1, okay? Ln of square root of e. You guys good with that? What's ln of square root of e? You good with that? Okay, so make sure you know how to plug in limits. All right, yeah, I'm not really sure why, but students have problems with these cosine sine problems, okay? And so what you want to ask yourself first is, do you have an odd exponent? Yes, okay? That means you save a cosine and change everything else to sine. That's what it means. So what I'm going to do is I'm going to save one of these odd exponents. So that's the one I'm going to save, okay? And I'm going to change everything else to sine. So actually, before I do that, let me just write what I have left, okay? Now, the way you do that, though, so the goal is to change everything else to sine. So let me box this in. I need to change all to sine 2x, basically, okay? This is already sine 2x, okay? So what I do is I use a Pythagorean identity to change this one to sine 2x. So this is going to be cosine 2x times, this is going to be, I think it's 1 minus sine squared, right? Sine squared 2x. And this right here is going to be sine squared 2x dx. Okay, so I've done what I need to do. I save a cosine and change everything to sine. From here, what I want to do is buy one, get as many free as I can, okay? And that just means get all pluses and minuses here, okay? Don't have anything that I can distribute. So what I'm going to do here is I'm actually going to distribute this, okay? So I'm going to distribute this cosine here. And the truth is you're only able to distribute 2 things at one time. There are actually 3 things here, okay? So I can only distribute 2 at one time. Let me distribute this cosine first. This becomes cosine 2x minus cosine 2x times sine squared, is it squared? Sine squared 2x, okay? And once you distribute this part, it actually becomes a quantity, okay? And what you have left over is this sine squared 2x, okay? Remember, I'm trying to distribute as many, as everything. I distribute everything before I stop, okay? Is there more that I can distribute? Yes, and it's actually kind of a backwards distribution, but this sine squared x can distribute this way, okay? So this new problem becomes cosine 2x. Now remember, I'm saving the cosine 2x. So the cosine 2x I don't change. Cosine 2x times sine squared 2x minus cosine, oops, I'm trying to get the same colors here, minus cosine 2x, okay, times sine squared times sine squared. Isn't that just sine to the fourth? Sine fourth 2x. And I think I'm done distributing. Okay, I think that's it. Okay, there's my distribution. All right, and the trick here is since I saved this cosine x, the derivative of sine x is cosine x, right? So it's going to cancel out. So what does that mean? Let me actually change these exponents. This is actually cosine 2x times sine 2x raised to the second power, right? Minus cosine 2x times sine 2x raised to the fourth power dx, all right? I saved the cosine. I changed everything to sine, and what happens here is that if I make the sine my u, if you add 1 to the exponent, divide by 3, what's the derivative of sine u? The derivative, cosine u times du dx. So this is going to be divide by the derivative of sine u, which is cosine u times 2. You see where I got the 2? Okay? And over here, when I make this my u right here, this is going to be you add 1 to the exponent, divide by 5, divide by the derivative of your u. What's the derivative of sine u again, guys? Cosine u times du dx, right? Okay, so come over here and say, do my x's cancel out? Yes, except I have this 1/6 now, right? So this is going to be 1/6 times sine 2x raised to the third power, okay, minus, do my x's cancel out over here? Yes, but do you see you have 1/10 here, and this will be sine 2x raised to the fifth power. Can someone check me on this? Okay, good. And that is my answer. Okay. I want you to note at the very top, you have this thing that says square root of a squared minus u squared, square root of a squared plus u squared, and square root of u squared minus a squared. I'm asking for your warm-up. How do you know that it's your phone? Okay? How do you know, like, if there's a phone out there, how do you know that it's your phone? Because why? It has your information on it, okay? But by just looking at it, can you tell it's your phone? If I put my phone down and you put your phone next to mine, how could you tell it was your phone? Okay, because your phone has a big battery case. Because your phone has, you know, it's green. Does that make sense? Or because your phone is large, my phone is small, or something like that. Does that make sense? You know your phone by the physical attributes that you see every day, okay? So, guys, what you have to know is when you look at this, you have to know what type of problem it is, okay? And with trig substitution, if you have a squared minus u squared, you already know it's a sine theta problem, okay? If you have a squared plus u squared, you're going to know that that's a tan theta problem. And if you have u squared minus a squared, what do you think that's going to be? A secant theta problem, okay? And I'm not completely sure why there are square roots here, but you don't have to have the square roots. You could have them, or you might not have them. It doesn't matter, okay? But with trig substitution, when you notice these patterns, okay, these physical attributes, that's how you know what type of problem it is. Of course, you always do u substitution first, okay? If it doesn't work, then you're going to move to trig substitution. And what trig substitution is the generic form of, you know how you did the arctan problems and the arcsine problems, arcsecant problems? It's the generic form of that, okay? So before we came in today, if I gave you a problem like this, 1 over, 4x squared plus 8 dx, okay, you would have looked at that and said it's an arctan problem, hopefully. Okay, you would have said that it was an arctan problem, okay? And remember I told you it's only an arctan problem if it fits your pink sheet exactly. But today what we're going to do is it's going to look like an ARC-10 problem. They're going to do something to it that makes it not look like one. Does that make sense? Not be it. And then you have to use trig substitution, because trig substitution is a generic form of your ARC-10 problem. Okay? It's a lot more work. That's why we teach you the ARC-10, ARC-sine, and ARC-secant, because those are something you can memorize. This is a lot more work, but it's also a lot more fun. Okay? So let me show you how this will work. If you have a sine problem, what you're going to have to memorize is, if you look at your notes, you'll see this. If you have a sine problem, you're also going to make it a cosine problem. If you have a sine problem, you'll also make it a cosine. On your next problem, you'll see if you have a tan problem, you're also going to make a secant problem. So if you identify a tan problem, you're also going to do a secant problem. And your next problem, if you identify it's a secant problem, you're also going to make it a tan problem. Okay, so just FYI, these are things you just remember. You only have 3 choices. It's going to be a sine problem, a tan problem, or a secant problem. Okay, so if it's sine, you're also going to do cosine. If it's tangent, you're also going to do secant. If it's secant, you're also going to do tangent. All right, and we're going to have to memorize all of our trig, SOHCAHTOA things again. Okay, so let's just go ahead and do a problem, and we'll see where we're at on it. Okay. Actually, maybe I'll let me do a quick review. I think you guys know, but let me do a quick review just to make sure you're comfortable with this. Sine theta is equal to, in geometry, opposite over hypotenuse. Remember that? Cosine theta is equal to adjacent over hypotenuse. And tangent theta, tangent theta is equal to opposite over adjacent. You agree with that? And I memorized SOHCAHTOA, but I never memorized the opposite. So like the reciprocal of sine is secant theta, right? So that's just the reciprocal of this, which will be h over o. Okay, I just memorized this is the reciprocal of sine, and so h over o is the reciprocal of sine. Okay, cosine theta, what's the reciprocal of cosine? Secant theta, so that's going to be the reciprocal of cosine, which is h over a. And then tangent theta, the reciprocal of that is cotangent theta. So cotangent theta will be a over o. Okay, so I'm assuming you have all of that memorized. Okay, we're going to go forward with this. Okay, and so if you have a problem like this, what you would say is, okay, let me try u substitution. I'm going to let you know u substitution doesn't work. Okay, and you look at this problem closer and you're like, you know what? I see an a squared minus u squared. Do you see the a squared minus u squared? Okay, I just wrote it on the board, so you have to see it now. Okay, but you see that, and when you recognize that, you're like, oh, what type of problem, guys? Sine theta. So what you'll write in your paper is sine theta is equal to u over a. Okay, you just have to memorize this. Sine theta is equal to u over a. Okay, when you decide it's a tangent theta, you'll say tangent theta is equal to u over a. Okay, students who recognize it's a sine theta and don't write u over a, you're pretty much stuck for the rest of the problem. Okay, so you need to know sine theta equals u over a. Well, what's u over a? Oh, well, my u is x squared, so u is x, and my a is 9, so my a squared is 9, so a must be 3. Okay, when you have a sine theta, you also have a cosine theta. Okay, so you're going to write cosine theta to the right, and the way you're going to figure out cosine theta is you're going to use a right triangle. Okay, and you're going to use this right triangle for a lot of things in this problem. So you're going to draw a triangle and you put your theta in. Okay, and what you notice on this triangle is you can already label the x and the 3. Why? Because sine theta is equal to opposite over hypotenuse, right? So opposite of your angle must be an x, and your hypotenuse must be a 3. You guys good with that? Okay. Using the Pythagorean theorem, and I'm not going to show you how to use it. Okay. What you should get here is this side here is actually 9 minus x squared. Okay. And if you're not sure how to do that, just think about it for a while. You'll get it. Okay. If not, come to tutoring. All right. So guys, this side right here is actually now my adjacent side. Now, so I've got my opposite, my adjacent, and my hypotenuse. What's cosine theta equal to? Is it adjacent over hypotenuse? So you use this triangle to figure out cosine theta. So that's going to be the square root of 9 minus x squared over 3. Okay, so think about what I've done. First, I recognize it's a sine theta problem. You write sine theta equals u over a. Okay, if you know sine theta if you know it's a sine theta problem, then you also know you have to do cosine theta. okay? To figure out your cosine, you draw a triangle, label your parts, and figure out your cosine, all right? On the left side, you're going to come back, and you're going to take the derivative of both sides. So I'm going to take the derivative of sine theta and the derivative of x over 3, okay? The derivative of sine theta is cosine theta d theta dx, right? The d dx, okay? The derivative of x over 3 is 1 over 3 dx dx, okay? And basically what I'm going to do is use substitution, okay? But it's really theta substitution, okay? So what I'm going to do is solve for dx, just like I did for use substitution. You solve for dx. You have to use real algebra here, so I'm going to cross multiply, and I'll get dx is equal to cosine theta d theta, okay? This part going down here was actually just like your use substitution problem, okay? This method called trig substitution is also called theta substitution. And what it means is come back up here, change all my integrals to thetas, no more x's, change it all to thetas. But you got to use real algebra. You can't just like say x is equal to theta. X isn't equal to theta, okay? Dx is equal to 3 cosine theta d theta. X is actually equal to, I don't know if you see this, x is actually equal to 3 sine theta. You guys see that here? If I cross multiply here, I'll get x is equal to 3 sine theta, okay? So what I'm going to do is I'm going to replace every part here with thetas. So let's replace the first part, dx. And guys, in use substitution, you always replace your dx and your u. Here you're going to replace your dx and everything else, okay? So what's dx equal to? Dx is equal to 3 cosine theta d theta. Do you see where I got that? Right here, okay? What's x squared equal to? Okay, come look at this. All the things I wrote here will act like a legend, okay? It's like a key that I'm going to use to go and replace all these parts. What's x squared equal to? Well, right here, x is equal to 3 sine theta, right? So what's x squared going to be equal to? 9 sine squared theta. Does everybody see where I got that? And all we're doing is replacing these parts, okay? What's the square root of 9 minus x squared going to be equal to? Look at everything that I have here. The square root of 9 minus x squared is going to be what? Cross multiply. This is really over 1, right? Do you see that that's going to be 3 cosine theta, right? I'm just going to cross multiply here. If I cross multiply, I'll get this is equal to 3 cosine theta. Okay, what's your goal? Your goal is to replace everything here with thetas, okay, using real algebra, okay? As soon as you get your new integral here, things are usually cancel out. Usually you have at least one thing cancel out. Sometimes a lot of things cancel out, okay? Do you see your 3's cancel out? Everybody good with that? As a matter of fact, your cosine thetas cancel out. They cancel out to 1. They don't disappear. They cancel out to 1. So if I were to rewrite this problem up here, let me move my triangle down. Okay. So if I were to rewrite this problem here, this is the integral of, well, how about this? This is 1/9 times the integral of 1 over sine squared theta d theta. Right? I mean, all I did was I canceled out things, and this is what I have left. Okay? At this point, this should be something that you can integrate. It should be something on your pink sheet, or it should be something that you can integrate. Is 1 over sine squared theta on my pink sheet? What's another way to say 1 over sine theta? 1 over cosecant squared. Do you guys, or cosecant, you see that? Sorry, not 1 over. 1 over sine theta is equal to cosecant, right? So this is actually the same as 1 over 9 cosecant squared d theta. Okay, so sometimes you have to use smarts. Basically, it's just definitions of your trig functions and also sometimes Pythagorean identities here. Okay, is this on my pink sheet? Yes, as a matter of fact, it is. So let me find some space to work this. Okay, this is on my pink sheet. The integral of cosecant squared is actually 1/9 cotangent theta. Is it negative? Yep. Negative cotangent theta plus c. And that is a great answer. Now, it is the wrong answer, okay, but it is actually a great answer. It is the answer to the U substitution problem. Does that make sense? Except this is called theta substitution. So all you got to do is go back and find out what cotangent theta is in terms of x's, right? If you ever want to find it, just go back to your triangle. So let's go look at our triangle. here's our triangle right here. Let me pull it up. Here's our triangle. Looking at this triangle, what is cotangent theta equal to? Is it adjacent over opposite? Is that right? Okay, so what's my adjacent over opposite here? Square root of 9 minus x squared. What's the opposite over here? X. And so all I do is come over here, replace my cotangent with the square root of 9 minus x squared over x plus Charlie, and that is the right answer. You see how nice that is? It's very similar to U substitution, okay, but it's theta substitution. All right, let's go for another problem. Let's go to your second problem. Okay, here it is. And the first thing you want to do is recognize it. You tell me, what kind of problem is it? Is it a sine problem, a tangent problem, or a secant problem? Tan, okay? And the tan is the only one with the plus sign. So this is a u squared plus a squared. If you look at the top, that's what I told you. U squared plus a squared is a tangent problem. Okay, let's work it out. The first thing you do is write tangent theta equals u over a. You always write that. Again, if you forget to write the u over a, you're going to be stuck for the whole problem. Okay, you need to write it's equal to u over a. Okay, what's my u in this problem? 2x. What's my a in this problem? 1. If you have a tan theta, you also have a what? Secant theta. So let's go ahead and set up your secant theta. Secant theta is actually adjacent, no, hypotenuse over adjacent, is that right? It's the reciprocal of cosine, right? Okay, so I need my triangle. So let me go ahead and draw my triangle. Okay. If I put theta there, okay. What's my, let's see, this is going to be opposite 2x. This is tangent, right? So it's opposite over adjacent. Do you guys see where I'm getting this opposite over adjacent? That's a definition of tangent. All right, so my opposite value is 2x. I label 2x there. My adjacent value is 1. I label 1 there. What's my hypotenuse going to be if this is 2x and this is 1? 4x squared plus 1. And a lot of times, guys, that missing side will show up somewhere in your original problem, okay? Maybe the the square root won't be exactly the same, but the expression-wise, it'll be very similar, okay? All right, knowing all the sides of my triangles, now I can find out what secant theta is. Secant theta is hypotenuse over adjacent. My hypotenuse is what? 4x squared plus 1, or square root of that. What's my adjacent according to this picture? 1. Okay, I'm almost there. Okay, first, I recognize the problem. It's a tangent theta. I set that equal to u over a. Okay, if I have a tangent theta, I also have a secant theta. I draw my triangle. I figure out my secant theta. I come back to the left side, and I take the derivative of both sides. Okay, so I'm going to take the derivative of the left side and the right side. What's the derivative of tangent theta? Secant squared theta d theta dx. What's the derivative of 2x? 2. Over here, just like U substitution, you're going to solve for dx. Okay, but just like U substitution, you want to use real algebra. Okay, not that fake stuff. Okay, so dx actually is equal to secant squared theta d theta over 2, I believe, if I did it right. Okay, all right. Then what you do is everything that you've done here becomes a legend for what you're about to do. Okay, just like you guys will become when you leave, a legend. Okay, so all of this here, okay, is going to help you plug in. But guys, what students forget to do, they do a great job with all of this, and then they forget to plug in the dx. The dx needs to be plugged in. Remember U substitution, you plug in your dx and your u. On theta substitution, what you do is you plug in your dx and everything else, okay? So let's look at, see what dx is. Dx is secant squared theta d theta over 2. So regular that. That's my dx. What's this square root of 4x squared plus 1 equal to in terms of theta? Secant theta. I have it right here, right? This would be times secant theta. And I think I've plugged everything in here. A lot of times things cancel out. Okay, I would say 95% of the time. Okay, do things cancel out here? Yes, as a matter of fact, the secant thetas, right? The secant theta is going to cancel out. So what I have left here is, I think 1/2 Secant theta, is that right? 1/2 secant theta d theta. Okay. Is this on my pink sheet?
Yes.
Yes, it actually is. What's the integral? Be careful. What's the integral of secant theta? Pull it out if you're not sure. Ln of secant theta plus tangent theta. Okay. So this is equal to 1/2 the ln of secant theta plus tangent theta. And I gotta say, I've told you this before. I printed this pink sheet because students won't believe me. Like some students will say, this is the integral of secant theta is secant theta tangent theta. That's actually the derivative of secant theta. Does that make sense? Okay. The integral of secant theta is this actual really long, terrible thing. Okay. And guess what? This is your answer. Okay. It's just the wrong answer. Okay. I know. But it is your answer. Okay. It's the answer in terms of u, basically. Okay. So all you got to do is go back to your triangle. Okay. Figure out what secant theta is. What is secant theta according to this triangle? What is it? Isn't it just h over a? Oh, isn't it just square root of 4x squared plus 1? Square root, okay? So instead of secant theta, we're going to put the square root of 4x squared plus 1. Okay? What about tangent theta? Use your triangle. What is tangent theta equal to? 2x, okay? And it just so happens it's over here. Okay? So tangent theta is equal to 2x. So that is your final answer. Okay? You guys good with that? Okay. You guys feeling more confident?
Yes.
Okay, well, let me see if I can destroy that. Here we go. Okay, let's look at this third problem. And you guys tell me, what type of problem is this going to be? You look at it and recognize its physical attributes. It's going to be a tangent. You've got a u squared plus an a squared. Now, had this not been here, it would have been an arc tangent. You guys see that? You would have been able to work this. It would have been no problem. Okay? But with this 3/2 here, it turns to a trig substitution problem. You have to do this long thing, unfortunately. The first thing you would do is you'd write tangent theta equals u over a. Okay? And then what you're going to do is you're going to define your u. Your u is x and your a is 1. Okay? If you have a tangent, you also have a what? A secant. So I'm going to have to draw my picture. Okay? It's always a right triangle. Maybe you knew and maybe you didn't. But SOHCAHTOA only works with right triangles. Okay? This tells me that my opposite side is x and my adjacent side is 1. So let me go ahead and label that in my picture. Okay? Using the Pythagorean theorem, I can get the hypotenuse is x squared, the square root of x squared plus 1. Okay? So using this picture, what is secant theta going to be? Well, what's the formula first? Is it h over a? Okay, so it's going to be hypotenuse, which is the square root of x squared plus 1 over 1. All right? Once I define, is that right? Oh, wait a minute. Okay, so then once I define secant theta, then I'm going to take the derivative. I'm going to go back to the left, and I'm going to take the derivative of both sides. Okay? What's the derivative of tangent theta? Secant squared theta, d theta dx. What's the derivative of x? Is that just 1? Okay? Then over here, you solve for dx, okay? So dx is going to be equal to, use real algebra, secant squared theta d theta. All right. Just like u substitution, we're going to substitute everything here. Don't forget to substitute the dx, okay? So this is going to be equal to, let me pull it out over here. This is going to be equal to secant squared theta d theta on the top. That's just my dx, okay? On my bottom, what is x squared plus 1 raised to the 3/2? Okay, and I think I'm going to rewrite this for you. Make sure you understand. This secant theta, isn't that really x squared plus 1 raised to the 1/2? Right? So if I wanted 3/2, okay, wouldn't you just cube both sides? Okay, so what would this be equal to in terms of theta? Secant cubed theta. I think that's the hardest part of this problem. Okay, seeing that this raised to 3/2 is really secant cubed theta. Okay, at this point I go to the integral and I say, what cancels out? Surely something's going to cancel out. So what cancels out here? The secant squared on top cancels out with the 2 secants on the bottom. So what I get is the integral of 1 over secant theta d theta. Okay, is this on my pink sheet? The integral of 1 over secant theta? No? Okay, can I change this somehow so that it is on my pink sheet? 1 over secant theta is really equal to what, guys? Cosine theta. Okay? This is really cosine theta d theta, okay? And what is the integral of cosine theta? Sine theta plus Charlie, and that is my answer. I have to tell you guys that this right here, this 1 over secant theta, what a lot of students would do on the test is they'll say that this is equal to cosine theta and forget the integral sign. Does that make sense? And you can see how easy that is to do that because you do so many things you forget to zip your pants. It's just so embarrassing, okay? But you got to know the integral sign is still there, and then you got to take the integral. So that's sine theta, okay? And that's a great answer. It is the wrong answer, okay, but it's a great answer because I can easily find sine theta. What's sine theta equal to? Opposite over hypotenuse. It's going to be x, right? X over the square root of x squared plus 1. And I replace that into my formula or into my answer, and there is my answer. Nice. All right, let's go to the last problem. Hey guys, let's look at this last problem here on the notes. If you look at this problem, you could try to do a u substitution. If you did u is equal to x squared minus 3, du dx would be 2x, all right? And dx would be du over 2x. So what would happen here is you would get square root, you'd substitute two things. You would substitute your u and you would substitute your dx. So this would be the square root of u over x times du over 2x, and your x's would not cancel out. So you think, okay, what can I do? I need to do something else. And so you might look at it and think this is a u squared. This is an u squared a squared, u squared minus a squared problem. So what type of problem is that? Yeah, it's actually a secant theta problem. So what I would do is I would say secant theta equals u over a. That's what you do first. You see that your u is x and your a is, be careful here, your a is not 3, your a squared is 3, so your a is actually square root of 3. All right, if you have a secant, then you have to just remember you also need a tangent, all right? And so how do you find tangent? Well, tangent is opposite over adjacent. I need a little triangle to help me figure out all of my sides. Okay, when I draw my triangle, what I see is since secant is x over square root of 3, secant is the reciprocal of cosine. So this must be hypotenuse over adjacent. So I'll put my hypotenuse as x. My adjacent side is square root of 3. This little side here is the square root of x squared minus square root of 3 squared, which is 3. And a lot of times this part here looks like this part here. Not exactly. In this case it is exactly, but not always exactly. And so what I do is I use this triangle to find my tangent theta. So tangent theta, remember, is opposite over adjacent. So opposite of this angle is the square root of x squared minus 3, and adjacent is actually square root of 3. All right, after I figured out it's a secant problem, okay, I set it to u over a, I find the tangent, and then I come back over here and I take the derivative of both sides. The derivative of secant is actually secant theta tangent theta d theta dx. The derivative of x over square root of 3 is 1 over square root of 3 dx dx. Then I need to solve for dx, and if I cross multiply here, that is square root of 3 times secant theta tangent theta d theta. All right, so I'm done with my legend. What I'm going to do is use my legend to fill in every part of this integral, like replace all the x's with thetas, okay? But it's not a simple replacement because x isn't equal to theta. As a matter of fact, here I can see that x is actually equal to the square root of 3 times secant theta if I cross multiply here. All right, so let me go ahead and rewrite this integral. On the top, I have the square root of x squared minus 3, and I can see over here, if I cross multiply here, that the square root of x squared minus 3 is equal to the square root of 3 times tangent theta. All right, so I'm going to put that on the top here, the square root of 3 times tangent theta. Now, on the bottom I have x, so I have to figure out what x is in terms of theta. And if I look here, if I cross multiply right here, I can get x is equal to the square root of 3 times secant theta. And that's exactly what I'll put in for x here, the square root of 3 times secant theta. Now, what a lot of times we forget is this dx, okay? Just like u substitution, you always replace two things. You replace your dx and your u. In trig substitution, you replace your dx and everything else, okay? So I've replaced everything else, but I also need to replace my dx, and hopefully you understand that dx is actually sitting in the numerator. So I'm going to copy this dx right here into the numerator. Okay, the dx is Leibniz notation. It works just like algebra. Okay, so it's actually in the numerator, and at this point, I have the new integral that I need to solve. It's just that something usually cancels out. So let me see what cancels out. The square root of 3 cancels out, and also secant theta cancels out. So if I rewrite this problem, what I get is a square root of 3 times the integral of tangent squared theta d theta. What I have to think about is this on my pink sheet. Is this integral of tangent squared theta d theta something I can solve? It actually isn't on my pink sheet. So what can I do? How can I manipulate this tangent squared theta somehow that I can actually take the integral by hand? What I have to remember is that 1 plus tangent squared theta is actually equal to secant squared theta, right? I tan in a second. So this can be rewritten as the square root of 3 times secant squared theta minus 1 d theta. And what I get here is a buy one, get one free problem. I have square root of 3 times the integral of secant squared theta d theta minus the integral of 1 d theta. Okay, it's actually two different integral problems here. And there are actually two that I can actually do by hand. So take a look at this. What is the integral of secant squared theta? That's tangent theta. What's the integral of 1 d theta? Be careful. A lot of students think that that's x, but this is a theta. So actually, the integral of 1 d theta is theta. Okay? And don't forget Charlie. And that's a great answer. It's not the right answer, but it's a great answer. Okay, what I need to do is go back and figure out what tangent theta is and what theta is in terms of x. Tangent theta is pretty easy. Tangent theta, if I use my triangle, I can see that tangent theta is actually equal to the square root of x squared minus 3 over square root of 3. So I can write this answer is actually the square root of x squared minus 3 over square root of 3. The question is, what is theta equal to? Well, I can solve theta here or I can solve theta here. I'm not sure which one's easier. Let me just go ahead and solve theta here with my tangent. If I wanted to isolate theta, what I'd have to do is take the arctangent, okay, of both sides. So I would take the arctangent of both sides if I wanted to isolate my theta. So what happens here is these are going to cancel out. So all I have left here is the theta. And on this side, I have the arctangent. And arctangent is also tangent negative 1, that notation, of square root of x squared minus 3 over square root of 3. Okay, so right here, what theta is equal to is the arctangent of square root of x squared minus 3 over square root of 3. Okay, and I would put the plus Charlie back, but really what I need is take this integral from square root of 3 to 2, and be careful. This is an x, okay? This is a dx, which means these values are x's, okay? These values are not thetas. If they were thetas, or if I convert them to thetas, then I could plug it in right here and get the answer, okay? But these values are x's, so if I plug in x's, I need to plug the x's into x's, all right? So this will go from the square root of 3 to 2. All right. From here on out, it's just a fundamental theorem problem, right? First, I plug in the 2, then I plug in the square root of 3, then I slap a minus sign in between. All right. I'm going to pull the square root of 3 out for a second, okay? And let me just multiply everything, do the fundamental theorem, then I'll put the square root of 3 back in. All right, so if I plug in 2, if I put 2 in there, that's going to be 4 minus 3, which is 1. The square root of 1 will be 1. So what I get is 1 over the square root of 3 when I plug in 2 for x. If I plug in 2 for x here, what I get is minus arctangent 1 over square root of 3. Okay, because again, 2 squared is 4, 4 minus 3 is 1, square root of 1 is 1. All right, let me plug in square root of 3. If I plug in square root of 3 here, I get 3 minus 3, which is 0, over the square root of 3, which is 0. If I plug in square root of 3 here, so this would be minus arctangent. If I plug in the square root of 3 here, I'll get the square root of 3 times the square root of 3, which is 3. 3 minus 3 is 0. So I get arctangent of 0 over square root of 3, which is arctangent of 0. So what I do is I plug in the 2, then I plug in the square root of 3, then I slap a minus sign in between. So now what's the question is, what is the arctangent of 0? Let's think about what the arctangent graph looks like. Remember, the arctangent graph looks like this, okay, with an upper asymptote, horizontal asymptote of pi over 2, and a lower horizontal asymptote of negative pi over 2. What is arctangent of 0? So if this is the arctangent curve, okay, if x is 0, what's y equal to? That's just 0. Okay, so this side really just becomes 0. On this side, this is going to be your answer, okay, but what is the arctangent of 1 over square root of 3? The answer to this would be the tangent of theta is equal to 1 over square root of 3, okay, or square root of 3 over 3, however you want to think about it. And let's think about the unit circle. Where is your tangent value, square root of 3 over 3? Right here and right here. And arctangent is on this side of the curve, so this actually here is pi over 6. That's the angle. This answer is an angle. So the answer is 1 over square root of 3 minus pi over 6 all times the square root of 3. And that is a great answer. It's also the right answer.